So problem goes like this: what will be the number of rows and columns in the resource block for 100 megahertz channel bandwidth? So in 100 megahertz channel bandwidth, how many rows and columns are there? 100 megahertz channel bandwidth, how many rows and columns are there? Huh. So in 5G NR new radio, the resource block is the smallest unit of resources allocated by the base station to a user. So it's defined in frequency and time. So this channel bandwidth, we have to convert it in terms of resource blocks, which has columns and rows. And columns and rows in the sense it, uh, symbols and subcarriers which are there in frequency and time domain. So in frequency domain, what do we have? In frequency domain, we have resource blocks which have 12 subcarriers. In frequency domain, we have 12 subcarriers in resource block. And in time domain, each resource block spans one slot. And that one slot has 14 OFDM symbols. 14 OFDM symbols when it comes to 5G and 7 OFDM symbols when it comes to 4G. So this 100 megahertz channel bandwidth we have to divide in terms of resource block which have uh, subcarriers in terms of in frequency domain and symbols when it comes to time domain. So those are the columns and rows. Columns 12 subcarriers columns and 14 OFDM symbols rows. So talking about frequency domain, so columns of resource block. So subcarrier spacing SCS. This is spacing between the adjacent subcarriers. So 5G it has numerology when it comes to subcarrier spacing 15, 30, 60, 120 and 240. So this is also called numerology. So mu 0 is 15, mu 1 is 30 and mu 2 60 and mu 3 is 120. Mu 4 is 240 kilohertz. So this each subcarrier occupies sub bandwidth which is equal to subcarrier spacing in hertz. So this each subcarrier it occupies the bandwidth in terms of subcarrier spacing in hertz. So columns in resource block that can be defined as resource block always contains 12 subcarriers, that is 12 columns. 12 subcarriers, that is 12 columns. This is fixed. So regardless of channel bandwidth or subcarrier spacing, each resource block has 12 subcarriers. And time domain rows of the resource block. So each resource block is defined over one slot and each slot consists of 14 OFDM symbols assuming normal cyclic prefix. This value is independent of subcarrier spacing except for different cyclic prefix types. So 14 OFDM symbols per slot, 14 rows, 12 columns and 14 rows. So these are just basic rows and columns which are present in the 5G NR. That is 12 subcarriers and 14 OFDM, 12 subcarriers columns or 14 OFDM symbols, 14 rows. But we have a problem. We have a problem like how many resource blocks present in 100 megahertz. So 100 megahertz we have to find out how many resource blocks are there in it, and uh, with the help of that we'll be able to find out the number of rows and columns. So this is where the channel bandwidth and subcarrier spacing come into picture. So when question is asked like this, the channel bandwidth and subcarrier spacing they both come into picture. So according to 3GPP specification, we have subcarrier spacing 15 kilohertz. Uh, Number of resource block they are not supported. They are because there will be too many of subcarriers, too many of the subcarriers. So the number of resource block it is not supported. This is a standard table according to 3GPP 38.104. So for 30 kilohertz we have 273. How we arrive at 273 we'll be able to find. I'll tell you how to find it out. So 30 kilohertz for mu 1 273, which is good for FR1 band, and 60 kilohertz mu is equal to 2, that is 136 number of resource blocks, which is good for FR1 and FR2 both, and 120 kilohertz mu is equal to 3, that is 66 number of resource blocks, which is good for FR2 millimeter wave. So this table we have to uh, have knowledge of this table. So with this table we'll be able to find out the number of rows and columns. So we'll be taking 30 kilohertz subcarrier spacing. Why? Uh, because more the number of resource block, uh, it is good. So we here 273, that is we'll be having 273 resource block. We know this from the standard table, so that's why we're going for 30 kilohertz. And in question also there is no mention of subcarrier spacing, so we are going with 30 kilohertz subcarrier spacing. So 100 megahertz we have to divide it in terms of resource block. So resource block size, how I have to find it out? So resource block size, I already have a subcarrier spacing of 30 kilohertz, but for 30 kilohertz we have 12 subcarriers, so 12 into 30 is 360 kilohertz. We have a resource block size as 360 kilohertz. This is our resource block. With the help of this resource block size, we need to divide this 100 megahertz total channel bandwidth in terms of number of resource block. So assuming 30 kilohertz, because um, 15 kilohertz it is not supported, and 60, 120 they are comparatively having lesser number of resource block. So 30 kilohertz, the resource blocks present 273, they are more compared to others, and this is good for FR1 band as well. So for 100 mega total bandwidth 100 megahertz, if we convert it in terms of resource block size, if at all we have to find if at all we have to convert this 100 megahertz channel in terms of resource block, we have to find resource block size. So assuming 30 kilohertz subcarrier spacing, we have 12 subcarriers. 12 into 30 kilohertz, we have 360 kilohertz as resource block size. So 100 megahertz divided by 360 kilohertz means we are dividing the total bandwidth, channel bandwidth, in terms of the resource blocks. That we'll be able to get it as 277 resource blocks. But in 277 resource block, we have certain resource blocks given to the guard bands. So assuming for 2 and 2 guard bands, we'll be having 273 resource blocks. So this is how we can arrive at a 273 resource block. No need to remember this. Uh, so this is how we got into 273 resource block. But we now have only we now have mentioned 100 megahertz channel bandwidth in terms of only resource block, that is 273 resource block. But in the question they have asked how many columns. So in order to convert this resource block into column, we have to multiply it with the standard columns, that is 273 resource blocks into 12 subcarriers, we have 3276 subcarriers. So number of rows, that is 14 symbols, that though those 14 symbols they remain standards itself, only the column frequency domain it changes. So this is diagram representation, means resource block grid, it is frequency into time. So columns will be having 273 resource block, 3276 subcarriers, that is with the 30 kilohertz subcarrier spacing we have 3276 columns, and rows it will be 14 OFDM symbols per one slot. So this is how we arrive at a number of columns and rows, and those columns will change according to the subcarrier spacing we take. For example, if in the question we have FR1, FR2, for both FR1 and FR2 we have to go for 60 kilohertz. If it is given like only for specifically for FR2, we have to go with 120 kilohertz, and for FR only for FR1 we can go with 30 kilohertz 273 resource blocks.